All right, here we go. Last section for chapter 7, 7.6. Vectors. And we are going to look at what's called the dot product. Okay, so this is just one of the ways to multiply vectors. So I already mentioned that, we specifically said, oh, scalar multiplication. And that's multiplying a vector by a real number. And I had mentioned that there are other ways to multiply vectors. You can multiply a vector by a scalar. You can do multiply a vector with a vector. And when we do that, there are actually two kinds. So there's something called the dot product, which we're going to take a look at. And then there's something called the cross product, which we are not going to look at. Okay. All right. So the dot product. So there are three types of multiplication when we're dealing with vectors. So that's why we have to be specific when we're talking about what kind of multiplication we are doing. We have scalar multiplication. So we saw that multiplying by a real number like 3. Okay. Scalar multiplication. Okay. And so something like this. Okay. And then here we're going to take a look at dot product. And this is going to be defined for you in a second. And then we also have the cross product. Okay. And we will not be covering this one. Okay. So will not be covered. Okay, so the dot product. All right, so suppose you're given these two vectors, vector u, some a component, b component, and vector v, c, and d. Okay, so suppose you have this, and then the dot product is found by the following. So and we use a dot. So, and you would, so here, let me write that up here. So dot product, you would do u dot v, and that's how you say it. And then cross product, you would say u cross v. Okay. All right, so u dot v is defined to be a times c. A is this x component and c is this x component. So you multiply the x component and then you add that with the product of the y component. Okay. So one thing to notice about the answer here. So this is a scalar, right? Real number. This is a scalar, real number. And when you add them together, you end up with a scalar. So just keep that in mind, because when you do the dot product, your answer is a scalar. Answer is a scalar, a real number, not a vector. Okay. So just keep that in mind as you are doing the dot product. Okay, so let's take a look here. Find each dot product. Okay. All right, suppose that we have this one, letter A, u dot v if u equals this vector and v equals this vector, 1, 7. Okay, so then u dot v is going to be 4 times 1 plus 5 times 7. So that's 4 plus 35, and we get a scalar, 39. Okay. Try this one. Suppose that we have these two vectors, -3, 2, dotted with 5, -8. So go ahead and hit the pause button and then come back and see if you get the same answer. All right, so we're multiplying -3 times 5 plus 2 times -18. So here we get -15 plus -36. So here we get um, did I do something wrong? I did. Okay, so I put a -18 here. Duh. Okay. 2 times -8 is -16. And then here we get -31. Okay, so that's what you should get. Okay, and let's try it with ij form. So if you have, let's go ahead and find s dot w if vector s is equal to 3i minus 6j, and w is vector w is 4i plus 9j. Okay. If you want to go ahead and try this and then come back and check your answer, go ahead and hit the pause button. All right, so S dot W is going to be 3 times 4 plus -6 times 9. So we get 12 minus 54, and we get -42. Okay, always a scalar, no matter what form we have. Okay, whether you have component form or vector component form, the ij form. Okay. All right. So another thing that is important when we're working with vectors is finding the angle between two vectors. So especially when you're dealing with physics or engineering and you're trying to figure out that angle between two forces. Okay, so angle between two vectors. All right, so given two vectors, u and v, vectors u and v, and the angle between them, and the angle between them, we'll call it theta, between them, theta, then u dotted with v is going to be equal to the magnitude of u times the magnitude of v times the cosine of theta. Okay? So here we have a formula that connects dot product with magnitudes and the angle between them. Okay, so you can use this to solve for theta, the angle between u and v. Okay, so use this to solve for theta, the angle between U and V. Okay. All right. So let's take a look at an example here. All right. Find the angle between U and V. Find the angle between vector U and vector V. Okay. And we'll do a few. Okay. Suppose that vector U is 3, 4. Vector V is negative 1, 2. Okay. All right. So if we use that formula, let me write it down here. U dot V equals magnitude of U, magnitude of V times the cosine theta. Okay. So I'm trying to find theta, the angle between them. Let me just solve this for theta cosine. Okay, so U dot V all over the magnitude of U and times the magnitude of V. Okay, equals cosine theta. All right, so let's do U dotted with V. Okay, so U dot V, so this is what we're using, right? Okay, so we're going to do this top part here, U dot V, 3 times negative 1, plus 4 times 2. And then let's do the magnitude of U. Okay, this part here, magnitude of U is the square root of 3 squared plus 4 squared. And let's do the magnitude of V. Okay, magnitude of V is going to be negative 1 squared plus 2 squared. Okay, so let's work this out. We get negative 3 plus 8 all over the square root of 9 plus 16, square root of 1 plus 4. So we end up with 5 in the numerator. 9 plus 16 is 25, and so that is going to be 5. And then 1 plus 4 is just 5, so square root 5. I can cancel these out, these 2 5s here, and I'll be left with 1 on top. Okay. All right, so cosine theta equals 1 over square root 5. So if I take the cosine inverse of 1 over square root 5, then I will get theta. And punching that into my calculator, I get 63.4 degrees. Okay, so that's how you find the angle between two vectors. You just plug into the formula. This was the original formula. All I did was rewrite it so that I solve for cosine theta. That way I just do all my calculations on this side and then take the cosine inverse. Okay, try it with this one. It'll be in IJ form, but it works the same. You can even convert your IJ vectors into component form if you want to. Okay, so give this one a try. Suppose vector U is 3i minus 5j, and vector V is 2i plus 5j. Okay, go ahead and find the angle between them. So again, we are using U dot V over the magnitudes. Okay, so let's go ahead and do this. U dotted with V, that's going to be 3 times 2 plus negative 5 times 5. Magnitude of u is going to be 9 plus 25. And then over here, magnitude of v is going to be 4 plus 25. Okay, so we get 6 plus negative 25. And then over here, square root of 34. And then over here, we get square root of 29. Okay. And here we get negative 19 over square root 34 times square root 29. So if I do the cosine inverse of negative 19 over square root 34 times square root 29, then I end up with 127.2 degrees. Okay. Yeah. Let me be consistent. Oops. All right, 127.2 degrees equals theta. Okay. All right, so again, it works the same way whether you have IJ form or component form. Okay, let's take a closer look. Okay, so let's take a closer look at that formula. Okay. So this is what we have, right? We have this formula. U dotted with V equals the magnitudes cosine theta, right? And then I took this and I solved this equation for cosine by dividing both sides by the magnitudes, right? And so I get U dotted with V is over the magnitude of U times the magnitude of V equals cosine theta, right? Okay, so let's take a look at perpendicular angles. Okay, so let's consider perpendicular angles or perpendicular vectors. Okay, so perpendicular means that they intersect at 90 degrees, right? So if I have one vector like this, let's call this one U, and I have another vector here, we'll call this one V, then they intersect at 90 degrees, right? Okay, so what is the cosine of 90 degrees? We know that the cosine of 90 degrees is 0. Okay, cosine of 90 degrees is 0. All right, so over here, so if theta is 90 degrees, then we know that this whole thing evaluates to 0, right? Well, if we know that this whole thing evaluates to 0, then that must mean that the numerator, which has the dot product, evaluates to 0, because we can't have 0 in the denominator. That would be undefined, right? Okay, so if this is 90 degrees, right? And remember, this angle theta represents the angle that's between U and V. So if this angle is 90 degrees, or in other words, if the two vectors we're talking about are perpendicular, then that angle is 90. So this would be 90. And if this is 90, then this dot product must be 0. Okay. So, so here, cosine 90 degrees equals 0. So that implies that this whole thing evaluates to 0, right? Which implies that the dot product equals 0. Okay. All right. So that is something to make a note of. Okay. So perpendicular vectors. This is kind of a big deal. Perpendicular vectors. We like to know whether or not they are, especially in physics and um, engineering. Okay, so perpendicular vectors. They actually have a special name, a fancy name. Perpendicular vectors. Um, that's not the fancy name. Here's the fancy name. Okay, so another name for perpendicular vectors is orthogonal. So orthogonal. Okay, and if they are perpendicular, then it turns out, and we just deduced that u dot v equals 0. Okay, their dot product must be 0. Okay, so let's take a look at these examples here, and we'll wrap it up. Okay, so which of the following vectors, which of the following vectors are perpendicular to each other? Okay, so here are the vectors. Vector u is 2I plus 5j. Vector v is 4I plus 10j. And vector w is 5I minus 2j. Okay, so which ones are perpendicular to each other? Well, we just have to check the dot product between them. And according to this, if the dot product equals 0, then they are perpendicular to each other. So, so let's go ahead. Let's check u dot v. So let's see if u and v are perpendicular. So the dot product between u and v is going to be 2 times 4 plus 5 times 10, and we can already see here that this is not going to give us 0. So they are not perpendicular. All right, let's do u and w. U dot w. U dot w, let me do that, is going to be 2 times 5 plus 5 times negative 2. And we see this is going to be a yes, because we do get 0. So yes. And then let's do v dot w. Let's see if v dot w is going to be perpendicular. We have 4 and 10. So 4 times 5 plus 10 times negative 2. Okay, and here we get 20 plus a negative 20, and we get 0, so we get another yes here. Okay, all right, so that's how you can figure out if vectors are, two vectors are perpendicular. You can, you don't have to solve for the angle between them. You just have to do the dot product. If you get 0, then the angle between them is 90 degrees. Okay. All right. If you have any questions, make sure you get a hold of me. Make sure you are keeping up with the homework, and make sure you check in for attendance.